All right, let's get to this. Section 6.4. Let's talk about these three words right here. Everybody look up here now. So it's rectangle, what? S, which means what? Rectangles compared to rectangle. It's more than one, right? It's plural, correct? Everybody look up here. Okay, we've had our time to relax. Now's my time. Everybody look up here. I don't think you're hearing me. So, what do I got on the end of this? An S, right? Because it's rectangles. This is squares. What is this? It's rhombi. That's it. It's rhombi. But what do you think that is? This is. You think this is what? Look, listen. What does that S do to rectangle? Thank you. It's more than one rhombus. That's right. If you guys would listen to me, maybe you might learn something. So the S makes that plural, the S makes that plural, but this is a weird one. They call it rhombi. It looks very similar to what? Rhombus. Okay. Rhombus is singular. What's rhombi? It's plural. Okay? Because these two are plural, right? So that's plural. So rhombi is just a word. I don't think we've ever said that before, but rhombi is the plural version of rhombus. I guess rhombuses, they didn't like that. They didn't like rhombuses, so they call it rhombi. It sounds kind of cooler anyway. All right, enough of that. Let's talk about a rectangle. We already know a lot of stuff about a rectangle, but we're going to learn one extra thing today about a rectangle. But let's go through what we already know. Okay, what do we already know about a rectangle? If I told you this is a rectangle, what could you tell me about the angles in that rectangle? They're all right angles. Very good. No, they're not acute. Okay. So you know that they're right angles. Shh. Listen. Come on, let's concentrate. So they're all four, you got all four right angles. If this is a rectangle, all right, if I told you that this was a rectangle, then all four angles would be equal to each other. Now, a rectangle is also a parallelogram. Do you agree? So what else might be true about this rectangle? What's true about the opposite sides? Okay, they are parallel to each other, but these tick marks mean what, though? They're congruent. Very good. Okay, or equal. Congruent, equal. Kind of the same thing, kind of. All right, so these two are equal. These two are equal. They're also what? Parallel. So I could say that. All right. Now, here's something relatively new. I think it was section 6.2. We did this. What is it from this corner to this corner? What do I call that thing? It's a diagonal. What did we know about the diagonals of a parallelogram? What did we learn about the diagonals of a parallelogram? What do they do? Okay, they intersect each other. Any two lines could intersect each other if they weren't parallel. Would you agree? Anybody trying to pay attention? Okay, let's try to think. All right, you guys are just waiting for me to tell you stuff. Don't just wait for me to tell you stuff. Okay, I'm asking you questions. I want you to think about what those answers are and not just goof around. So let's think about what the answers are. We've talked about this in section 6.2. Look at your notes. If you got your notes out, you should have your notes out. What's true about the diagonals of any parallelogram? What do they do to each other? They're not on any parallelogram. Supplementary line segments can't be supplementary. Only angles can be. You're just throwing out words, geometry words that are floating around in your head. Let's think about it. These two, the question is, this is impossible. How do you learn anything? Listen to me. Let's pay attention. The diagonals of a parallelogram, okay, not talking just specifically about a rectangle, but of any parallelogram, what do the diagonals do to each other? They bisect each other. Thank you. Okay, they bisect each other, which means this is equal to this, and this is equal to this. Agreed? But watch this. Here, that's all old stuff. Okay, all the stuff we just talked about is stuff that we already knew. All right? We haven't done anything new yet. Right? Here's the new stuff. I'm going to let's make them the same color. On the other class, I made them two different colors. Let's make them the same color. All right? Now, here's the new stuff. The new stuff says, it talks about the diagonals. That's why I made those red. It talks about the diagonals. We already know they bisect each other, correct? But what do you think? And somebody said it earlier. But what do you think might be true about the diagonals of a rectangle in particular? Look at these two red ones. What does it look like they could possibly be? Look at it. Everybody look at it. Congruent to each other. Exactly right. So if I call this ABCD, what do you think you could say? You could say that AC, what do you think? Is equal to BD. Very good. You can say DB. It doesn't make any difference. All right? Everybody see that? That's the new stuff. That's the thing that we're learning today. All right? And let's write it down so we know what that means. So it's the diagonals of a what? Is that any parallelogram? Is that true? No, because look at this. Watch. I'll just sketch a parallelogram that we're kind of used to seeing. Would you agree? And if I do the diagonals, oops, terrible diagonal. If I did that diagonal and that diagonal, does that mean those two diagonals are equal to each other on just a regular parallelogram? No. They're only equal to each other when it's a what? The diagonals of a rectangle. Okay? The diagonals of a rectangle are congruent, we'll call it. All right, so that's the new thing. That's the only new thing that we've learned so far today, all right, is that the diagonals of a rectangle are congruent. So that means that AC is equal to BD. Let's go back a little bit to what we just talked about. We also said on a parallelogram, what do the diagonals do? They bisect each other, correct? So now think of this. If AC, let's just say AC was 10, all right? Everybody with me? So if I said that AC was 10, let's put an E right there. If I said that AC was 10, what is BD equal to? It's also 10 because they're both diagonals, correct? Then what would AE be equal to? It'd be 5. Okay? We already did this in the past, in lesson 6.2. We said if this is 5, then this is 5. But in the past, when we did a parallelogram, these two are always different, weren't they? But this time it's a rectangle, so if this is 5 and this is 5, what is BE? BE, from here to here. That's also 5. And what is it from D to E? That's also 5. And you know what they're going to do. We're going to do an example here in a minute, all right? Probably less than a minute. If they said this was 5 and they say this was like, I don't know, x plus 2 or something like that, what would you do with this x plus 2 and that 5? Well, you can't plug anything in yet because you don't know what x is. So what do I do? What's true about this little segment, CE and AE? They're equal to each other. You got it. X plus 2 equals 5, okay? What if they told you, like AC was like 3x plus 1, and they told you BD was like 5x minus 2 or something like that? What would you do with those? Set them equal to each other, all right? Everybody with me on that? Okay, so let me get rid of this stuff because we're not using these numbers. I'll just, oops. Let's try this again. There we go. I'm going to use the same picture so I don't have to redraw it. And let's put something in here, okay? I guess I probably should have just drawn it. I probably could have done that quicker than erasing all these things. All right, everybody watching? You're writing this down. Did you draw that picture? You should have drawn it. Everybody should have drawn it. So that's JKLM. And this is N in the middle. All right, I changed the letters a little bit. That's okay. Here's what they do. They tell you, they don't draw it on the picture, all right, but they will write it down. They tell you that JL is equal to 5x plus 2, all right, and they tell you that KM is equal to 7x minus 6, and they want you to find MN. All right, so that's what we're looking for. Where is MN? It's from here right to that point of intersection. That's what we're trying to solve for. Everybody with me? All right, what do they tell you though? They tell you JL. What is JL? It's that whole entire diagonal, isn't it? They also tell you KM. It's what? That whole entire diagonal. What's true about both of those diagonals? They're equal to each other. So what am I going to do with this and this? Set them equal to each other. You could go 5x plus 2 first, but I like to go 7x minus 6 first. Yeah. Everybody see that? You know why you did that? The reason you set them equal is because the diagonals are equal to each other. So if they are equal to each other, you set their measures equal to each other. Let's do the math real quick. We've done this a million times. Well, maybe not quite a million, but close to it, it seems like. And then, was this minus 6? Yeah, it is. Okay, then what do you do here? Add a 6, add a 6. That cancels, that cancels. 7x minus 5x, 2x equals 2 plus 6 is 8. Divide both sides by 2, right? You could do this in your sleep, couldn't you? You've done this so many times. You should be able to, well, maybe not do it in your sleep, but pretty easy. So x equals 4. What are we trying to find? Mn. Well, I don't know what Mn is, but I could find Km, couldn't I? Or I could find JL. It doesn't matter which one because they're both the same. So let's find Km. So what's Km equal to? 7x minus 6. So let's plug it in. So 7 times 4 minus 6. 7 times 4, 28. Minus 6 is 22. Does that mean Mn is 22? No. Look, what's 22? The whole thing is 22, isn't it? All right. But what am I looking for? Half of 22, which is 11. Let's put it down so that you see where you got it from. All right. So Mn is 11. Now, that's the only thing they ask for, okay? But what if they ask for Jn? That would be 11. What about if they ask for Ln? 11. Kn? 11. You get it. Make sense? Yeah. Okay. Let's do something else. So what was the second thing? We did rectangles. Well, we did a couple rectangles. And then we were going to do what? Rhombi or rhombus, right? We're just going to do one rhombus. And there's two things that we know, two new things that we're going to learn today about a rhombus. Okay. Let me just kind of make it look a little more equal, those sides right there. Okay. And we're going to learn something about these diagonals. Let's do them in red. So there's one diagonal, there's another diagonal, and there are going to be two things that are going to be true about these diagonals. Now, it's a rhombus. So what do we already know about a rhombus? What's the thing that makes a rhombus different than a rectangle or just any normal parallelogram? What's true about the rhombus? All four sides are what? Are congruent or equal to each other, okay? So all four sides. I'm not going to mark it, but they do tell you that it's a rhombus. All right? So we know what's true about a rhombus. What's true about a rhombus? All four sides are equal to or congruent to each other, okay? Everybody with me? Now here's the new stuff, okay? I just want you to guess about this first thing. Look at the angle that's formed with those intersection between those two. What does it look like? Okay, it's true. They are all congruent. So if they're all congruent, give me a number. It looks like 90, doesn't it? See this angle right there? No, that looks very 90 to me. I don't know what you're looking at. But this angle right here absolutely looks like a right angle. Okay, well, I was pointing to this one, okay? This is the one I was asking about. That definitely looks like a right angle, doesn't it? Okay, and it is a right angle. I'm not going to go through the reasons why it is. I don't think you'll really care. Plus, we don't have much time. But this is a right angle, okay? So what can we write? We can say, how do they say this? The diagonals. What do we know about two lines that form a right angle? What do we call those two lines? We say they are what to each other? No. No. Two lines that make a right angle. Look, if you got this and you got this, okay? These two lines are what? This would be what? Okay, everybody knows that one. Okay, yeah, thank you. Okay, these would be what? Perpendicular. If they form a right angle, those two lines are perpendicular. So what we're going to say, we're talking about diagonals, aren't we? We're talking about two line segments. So the diagonals of a rhombus, what do you think we're going to say about it? Are, well, just you don't have to say line segment. You can just say are perpendicular. All right? So that's really important. Perpendicular. Okay. All right, so the diagonals of a rhombus are perpendicular, which means what? It means it's a right angle. What about this angle right here? What's that angle right there going to be? It's also going to be 90, right? What's this angle right here going to be? That's also 90. And what's this? That's also 90. They're all 490s. Got it? Okay. That's our first thing that we know, our first new thing that we know about a rhombus. Okay, we got one more new thing to learn about a rhombus. So let's go change colors on this. Do you see how this diagonal is hitting this big angle right there? Again, what does it just look like to you with that angle and that angle right there? It's what? They're the same? Yeah, they are the same. Exactly right. What's a good word that we use in geometry? Instead of saying they're the same, what did it do to that whole entire big angle? What did that diagonal do to this angle right there? It split it into two equal angles. What is that word? It's bisect, right? Okay, so that diagonal bisected that angle. Everybody see it? So the red line right there bisected that big angle, which means it split it, how? Into two equal angles. That's right. Everybody with me? So check this out. What if I told you that the whole big angle was, let's say, 60 degrees? We'll make it easy. Then this little angle right there is going to be 30 degrees. What's this little angle? That's also going to be 30 degrees. Now watch this. Let's take it a step further. Shh. Zion. So the whole big angle is 60. This is being bisected, so 30 and 30. We learned something in section 6.2 that said something about the opposite angles of a parallelogram. What are true about the opposite angles of a parallelogram? They're equal. They're congruent to each other. So what is this whole big angle right there going to be? That's also going to be 60, which means this little angle is going to be 30, and this little angle is going to be 30. Okay? You with me? So watch this. Let's think. Stop the talking and pay attention and think. So what's this whole angle right here going to be? Right. It's 180, right? Because remember, these are supplementary. Remember, consecutive angles are supplementary? This is why we learned all that stuff earlier, so we could use it again, right? So if this is 180, right, minus 60 gives you what? 120. Yep. So this one up here is also going to be 120. Which means, what are the little angles right here going to be? That's going to be 60, and this little angle is going to be 60. And this is 60, and this is 60. All right, let's do an example, though. All right, let's do an example. Let me grab this. Now, this is only true when your figure is a what?
Perpendicular.
It's a rhombus. Look what I'm helping you out. I'm circling this. It's a what? It's a rhombus, okay? This only works when you have a rhombus. By the way, I should have written this down. I don't think I wrote it down in the other class either. Okay, it says, I'm running out of time. It says the diagonals of a rhombus, okay, it starts off like the other one, but it doesn't talk about forming that right angle. What do? They bisect. How do I write that? Two opposite angles. Two opposite angles. Does that make sense? So that diagonal, it bisected that angle and it bisected that angle. Right? This diagonal right here bisected this one and it bisected this one. All right, that's what it says. All right, let's do this. Let's move on. And I'm going to put some diagonals in here as well. Yep, same rhombus. I mean, they all look the same because, well, they don't all look the same, but anyway. All right, I'm going to ask you a lot of questions about this. Ask 6 questions about it. A, B, C, D, and I'll tell you right now, since I'm running out of time, if I don't finish this, I did finish it in the other class. So go and watch the last bit of that in the other class. So let me write that. We might be able to finish this if I go kind of quick. I don't have to tell you to be quiet 10,000 times. All right, this is... Now, this is really not drawn to scale. I probably should have flipped it the other way. I'll show you in a second. All right, so here's what we're finding. We are going to find angle... We're finding 6 different things. Angle 1, angle 2, angle BAD, angle 3, angle ABC, and angle 4. This is way easier than what it looks, I promise. Okay? All right, so let's take a look. So look at angle 1. Super easy, no math involved. What's angle 1 equal to? Yeah, because it's a rhombus and it's being, right, the diagonals of a rhombus are perpendicular. So that's 90 degrees. So angle 1 is 90 degrees without any math at all. Everybody should be able to see that. Okay, where they intersect each other is 90. Angle 2. 34. That's right. That's 34 degrees because it's being bisected. Okay, again, without any math at all. Here's a little bit of math. BAD, where's that? Angle, let's do a different color. Angle BAD. BAD, I'm talking this whole big angle right there. It is, because this whole big angle is equal to this whole big angle. All right? What's this whole big angle?
68.
It's 68, because 34 and 34 is 68, right? And so that whole big angle is what?
68.
It's 68. All right, so let's write that right there. Then angle 3, where's angle 3? That little one right here. That's right, because it's half of this. Remember, all 4 of these are exactly the same. All right, so you just 68 divided by 2, or you could just look down here and say, oh, that's 34. So these 2 up here are both 34. Again, the only math we've done so far is just 34 plus 34, isn't it? Yep. All right, ABC, ABC, let's do a different color. So ABC is this one. That whole angle, how do I find that whole angle? We did this just a minute ago. Remember, what's this whole big angle down here? 68. So how do I find this one? They're consecutive angles, aren't they? So it's 180, what? Minus 68, which is 112. So this whole thing is 112. So that's what this is. Angle 4. How do I find angle 4? That's it. Take 112, divide it by 2, and that's 56 degrees. Don't get up. We're not, bell didn't ring. All right, so here's your homework. Now, we are not exactly finished the lesson. There's a few other things, but I think you should be able to do most of the homework even without doing the other stuff, okay? So it's section 6-4, and we're doing 1 through 11, all right? 1 through 11. So get that finished for tomorrow. We'll go over that tomorrow. We'll review for the quiz tomorrow. We'll take the quiz on Wednesday.